Hello, now here we'll try to understand and see about Archimedes principle. Archimedes principle. Now this is one of the very important and at times bit confusing principle. So we'll try to see here means first of all what is this Archimedes principle, then how it works and why it works. Maybe why it works so goes into more intricate details of fluid mechanics. So we'll try to restrict ourselves here mainly upon what is Archimedes principle and how it works. The simple, I'll say the statement of Archimedes principle is that whenever an object, any solid body object is immersed, immersed means it should be immersed either partially or completely. If an object is immersed partially or completely in a fluid, fluid we know is the general term for gases and liquids. In our examples we generally consider it to be a liquid. In a liquid, then this object, it loses some weight, and that loss in weight is equal to the weight of the liquid displaced. Now seems to be a bit confusing. We'll try to simplify it and understand it. So first of all, let's complete the definition. When an object is immersed partially or completely in a fluid, it loses some weight equal to the weight of liquid, or I should have written fluid in journal. It's the same thing, this fluid and this liquid, uh, weight of the liquid displaced. Now let's understand how it works. Now to understand it, let's understand it through some experimental setup. Let's assume that we have a solid object, means for a sake of simplicity, for the sake of imagination, you can imagine it to be a stone, a simple stone, a simple ordinary stone, right? Then what we do is we, let's say, measure its weight with the help of a spring balance. Now let's say this is our spring balance. Spring balance we know measures the weight, so this is the spring balance. We attach it here, and the spring gets stretched according to its weight, and let's say it shows some reading. This is its weight. For the sake of generalization, let me call its weight is W1. So W1 is the weight of this stone, and we are doing all this in air. In air. So in air, the weight of the stone comes out to be W1. Now what we do next is we immerse this stone in some fluid. For the sake of simplicity in imagination, let's take it to be water. So let's consider कि this is one beaker having water, or it could be an overflow can. This is water, and from here the water will overflow and it is filled to the brim, and this is another container to collect the overflow, and we take this whole setup and just immerse the stone, the same stone. This is our same stone. It's the same stone, or you can assume it the same time. So same stone is immersed here, and it has the spring balance, the same spring balance here now, right? And now what do you think? What should be the reading in the spring balance? Should it be same W1? Will it increase or decrease? Yeah, well, we know from our experience that when we are in a liquid, we feel lighter. We feel less weight. Let's say now the spring balance gives some another weight which is W2, and W2 is less than W1. We know it from our experience. And moreover, some water gets displaced, it's collected here. So this is the displaced water. So this is displaced water. Now let's clarify again. This in general could be any fluid. For the sake of easiness in our imagination, we are considering it to be water. Now this water which is displaced here, it has some volume, some quantity. Now simply common sense dictates us that when this solid body stone was immersed in this fully filled to the brim this displaced can in which there was a water, when this stone goes in, it displaces some water. So whatever is the volume of this stone, the same should be the volume of this water. Make sense? So we can say volume of solid body or the immersed body, whichever is here dipped inside it, its volume is same as volume of liquid or fluid or water, in this case liquid displaced. So the two are equal. Now moreover, here we see that because of the upthrust or buoyancy, W2 is less than W1. So this difference in weight, W1 minus W2, is equal to this W1 plus W2 is equal to the weight of the liquid displaced, meaning that this weight of the liquid displaced, this liquid whichever is displaced, whatever is the weight of this is equal to the difference in their weights. Now this difference in weight, whatever we are getting, W1 minus W2, W1 was the weight in air and this W2 is the weight of the body when it is immersed in liquid. So this difference in weight is equal to the weight of this liquid displaced, whatever is the weight of this liquid, and the volume of the solid immersed is equal to the volume of this liquid displaced. Now there are further some problems and calculations based upon it, but this is the basic essence, I'll say, of Archimedes principle. Now let's in few moments revise what all we have done. So in Archimedes principle we have done that the definition of it says that whenever any object or a solid is immersed partially or completely in a fluid, in a liquid, it loses some weight, and the loss in weight is equal to the weight of the liquid displaced. And what we have understood here is that we have a stone here whose weight in air is W1, weight in water is W2. The difference in weight is equal to the weight of the liquid displaced. Thank you.